Welcome everyone. In this video I'm going to work with the milliohm meter again. So in my previous videos you could see that I assembled this thing. I programmed an Arduino Nano to drive the thing and read out the values, and I measured a few simple resistors just to see if it works properly. But then I got 5 PCBs in total, so I still had 4 PCBs left. And I decided to order the parts which I need to complete all these 4 PCBs. So what I will do in this video, I will assemble these circuits and I will test them one by one, and hopefully all of them will work properly. And then I will figure out some different kind of enclosures and different kind of terminals, connectors, and so on for them. And why I decided to do this, despite the fact that these are quite expensive parts, is because I think it's quite fun to work with this circuit. And then it also has some challenging parts in terms of soldering. So I want to practice soldering as well, especially for those tiny SMD parts. So I will do that. And in this video, I'm going to focus more on the soldering and assembly part under a microscope. So I will use my microscope camera, and hopefully we'll be able to create some nice footage so you can hopefully enjoy those things. So for those who see this video for the first time visiting my channel and haven't seen the other, this is a milliohm meter which I designed on this PCB based on 2 different circuit designs from another maker, and I just combined his designs into this PCB board. So the basic principles of this board is quite simple. We have a current generator which generates a known stable current, and then that current is connected to an unknown resistor, and then there will be a voltage drop on that resistor because of the current, and we can measure that voltage. So the other part of the PCB will make sure that we can measure that voltage relatively precisely. And based on the Ohm's law, we can easily calculate the resistance of our unknown resistor. And based on the design of this circuit, the highest resistance value which we can measure is 5 ohms, but this circuit is designed more to work in the milliohm range, or even below that, but more like in the milliohm range. So don't expect to be able to measure, let's say, 10 kiloohms with this specific circuit, because that will just not work. So as you can see, I have this gorgeous white PCB. And this PCB is, as I said, designed by me. And then it is made by the sponsor of this video, PCBWay. And first of all, if you want to get this PCB, go to the link in the description down here, or go to my website, and you can click on the link and you will be redirected to PCBWay's website, so they can make this exact PCB for you. But also, if you are an already experienced PCB maker, make sure that you go to their website and assemble your own PCB board based on many customizable options. And if you are like me and you have a lot of SMD parts, don't forget to order a stencil, because that will make your job much easier. They can also provide PCB assembly services, as well as they can also source the parts for you. So again, they can make your project much more easier. And if you want to elevate your PCB design and you want to make a fancy front panel or an enclosure, they can also offer CNC services, 3D printing, sheet metal forming services, and many other services which can help you to have a nice finished project. So don't forget to visit their website and check out all of their amazing services. So now what I did here is basically I sort of put all of their parts in their correct alignment to one of the PCBs, and that will be my cheat sheet. And then I will work first on one of these 3 PCBs. So I will check how I should put the part on the other PCB and solder them one by one. And there will be some steps where I will sort of stop with the assembly and do some measurements. More specifically, I will measure if the 5 watt low dropout regulator really gives 5 watts. And then I assemble the current regulator part, and I will make sure that I get around 100 milliamps, because that should come out on the current source part. And then I put together the ADC part, and that will be another, let's say, checkpoint, because together with the ADC and the voltage reference, I will have another voltage which I can measure, which is the reference voltage, which is 4.096 volts. And once all these systems work, I just put together the differential amplifier part, and then I will just insert an Arduino Nano, which I have already prepared and programmed, and insert a connection for the display, and see if the circuit works. And then I will do this with all of these circuits. But what I will do in the rest of the video, probably without any comments, I will just show you some nice footage, hopefully nice footage with the different soldering parts, and then we will see. When all the 4 things are done, I will just make the same measurements on them and summarize the main things that we learned during this project. So let's switch to the other camera, and let's see the individual parts, and let's see how the soldering is going on. So after roughly 5 hours of work, I'm finished with all these 4 circuits and all of them working well. I tested them by a pre-programmed Arduino, so I uploaded the same code that I showed you in my project previously, and I used the same type of OLED display with the I2C connection. So everything works properly, and the measurements seem to be okay. So I can measure the values which I supposed to get based on a known resistor value. But the thing is that these potentiometers are not yet trimmed. So yes, I measure the values roughly, but I could improve this. So how does that work? I explained this in my previous video, but let's just quickly go through it again. So we have 2 trimmer potentiometers here, and one, which is now revealed, is for the voltage input. So there is this precision differential amplifier, and we can sort of shift its input level by trimming this resistor or potentiometer. So we just have to short the inputs and change this potentiometer until we receive 0 voltage on the input of the AD converter. And after we are done with that, we know that the baseline is, or I don't know how to say it, it is set up properly. So let's say the voltmeter part is set up well. But then we have the current source part. So now this revealed potentiometer belongs to that resistor network. And what we have to do here is a bit more tricky, because we have to be sure that we measure the 100 milliamps. So I think that the best idea is to have a known resistor with a very precise value and measure the voltage with our already set up voltmeter or another high precision voltmeter, and adjust this potentiometer until we receive either 100 milliamps with a very good current meter, or we measure the corresponding voltage based on the known resistor value. And I will do that because I bought this. Maybe it's a bit a crazy idea, but I have this resistor from PCBWay, and this is a 1 ohm resistor with 0.02% accuracy, which means that we should read 1 ohm plus minus 200 microohms. And I can live with that plus minus 200 microohms precision, because I am mostly interested in the milliohms region. So I will use this resistor and use this and say that this is 1 ohm and adjust the current, so I precisely read the 1 ohm corresponding voltage, which before the precision amplifier should be 100 millivolts, because we have 100 milliamps. But then this amplifier has a times 10 gain. So then actually the voltage which is read by the LTC 2400 AD converter is 1 volt exactly. But of course we treat these numbers in the Arduino, so I will know that the real voltage on these wires, which will be connected to this thing, is really 0.1 volts. So what I will do, I will just show you the calibration with one of these units. All of them work, so it should be identical process, just to show you and just to give you a feeling about how this thing works. So I have set up everything, and I just started the circuit. So here I supply 9 volts, and that goes into the LDO and then feeds the rest of the circuit. We have the display here, and now it's showing obviously wrong values. And then I have shorted the inputs with a clip. Maybe not the best solution, but it seems to work at least. So power is on, Arduino is on, and now you can see that we are at 409.58 millivolts. That's the voltage which is being measured. So now I have to trim this to change this voltage to possibly 0. And now we are getting to 0, but not there yet. Of course, it would be nice to use a bit more digits. That would help. And the problem, or not really a problem, but the thing is that I have to wait for a few seconds before I see the new value, so that takes a bit of time to properly adjust this resistor to really zero out the values, because the voltage is being averaged 10 times. So it seems that I cannot really reach very zero, but you can see that the resistance anyway gives us the values in microvolts. So this is 40 microvolts now here, 0.04 millivolts. So this is, let's say, enough for us. So then I will move to the next part, which will be the part with this resistor. So I will try to connect all the terminals and everything, and then we will measure what's up there. So I assembled everything, and I made a very funny connection here, so maybe I will put some pictures on the video because yeah, it's a very funny connection, but I used some clips and wires to set this thing up. And just for the sake of safety, just to be sure that we are not measuring anything stupid, I also added the voltmeter here, and we can measure the voltage. And I will just try to adjust the angle of it, because probably it's not showing up the best way in the video. So now you can see, and I set this up as millivolts. So 97.47 millivolts, and actually we are also measuring 97.51. So that is 40 microvolts, if I'm not wrong. That's quite okay for this level of instruments. But this 97 says that that's not 100. So then I have to adjust the current with this potentiometer and try to read 100 here and as well as here. So then we will know that, okay, we are measuring the resistor as we should measure it. So let's try it and let's see what happens. So then you can see that we succeeded, sort of, without doing too much work on this. I could reach 1 ohm exactly, or 1000 milliohms. And that is very well visible that, yes, we have 100 millivolts exactly. And now the current source here is exactly 100 milliamps. So just using the Ohm's law, that gives us the 1 ohm exactly. So this is, I think, very nice. And you can see that this last digit, which is now 1, is 10 micro ohms. So that kind of uncertainty is pretty much good for me. And you can see that we have still that 40 microvolts difference between the two measurements, but I have to say that the cable or cables which I'm using for attaching the clips to this voltmeter cause a drop. So it might be that actually that missing 40 microvolts is caused by the voltage drop on the cables. So I think these two values are close enough. But even though if we would say that all the cables and everything connections are perfect, I would say that I don't really care about the 40 microns difference. So for me it's fine. And yeah, I just have to do this with the rest of the circuits, and I'm done. And I have to remember that I have to do this also with the project which I put already in the enclosure. because I haven't done this kind of calibration there because I did not have this very precise 1 ohm resistor. But yeah, so this was the, let's say, assembly and maybe more fun part of this circuit from a bit closer perspective using my microscope camera. And then I also showed you how to sort of trim it and let's say calibrate it. It's not a true calibration, but for a homemade circuit it's pretty much enough. And I think there are more mistakes in my soldering and stuff like that, which could also change the readings. So I'm pretty much satisfied. So this was the whole video, and I hope you liked this kind of assembly and this kind of soldering and adjusting things. For me it was quite entertaining, and I learned a lot and did a lot of practice with the hot air gun and so on. So if you want to get this PCB, you can go to PCBWay.com, and then you can check out their services as well. So you can have anything that you want related to this project or for your own project as well. So I hope you learned something. I hope you found this video useful and entertaining, and see you in the next video.